As you remember, till now we have discussed about defects in buildings, introduction to defects, defects in timber, defects in steel, defects in sanitary fittings and plumbing. After that we discussed about repairing materials, in which we discussed repairing materials for defects in timber, then repairing materials for defects in steel. Then we discussed about repairing materials for defects in sanitary fittings and plumbing, and finally we discussed about repairing materials for miscellaneous defects. Now we will focus on repairing and preventive maintenance. In this, we will begin with the repair of floors, and today we will discuss about the type of floors. The objectives of this module are that after going through this module, you should be able to explain various types of flooring, and also you should be able to identify various defects in flooring. Let us begin with the types of floor. So let's begin with the types of floor. Criteria for selection of flooring include: number 1, cleanliness; second one, wear resistance; third one, chemical resistance; fourth one, appearance; fifth one, acoustics; and finally last one is anti-slippery. Means if we talk about these criteria, means how easy or comfortable is to clean the floor. Then according to the second criteria, that how much wear resistance it provides. Then how much chemical resistance the floor provides. Then appearance, that it should give a good appearance. Then acoustics tells us about that there should not be echo, it should absorb the sound. Then of course very important thing is that any flooring which you are providing in any building. So let us see what are different floors which we can use from different criteria. In order to achieve cleanliness, the usual types of flooring are: first one is cast in situ terrazzo, second one is precast terrazzo, and third one is polyvinyl chloride or PVC. There are some more also like this. These flooring are normally provided in offices, banks, hotels, laboratories, residences, schools, hospitals, and institutional buildings. Keeping in view the wear resistance, flooring is usually provided by Indian patent stone, normally called as IPS flooring, or grano, also ironite, reinforced cement concrete RCC, then metal flooring, then polyurethane, etc. These floorings are provided for industrial buildings, warehouses, ports, public utility places, etc. Then chemical resistance floorings are provided with acid resistant tiles, PVC, polymer, ceramics, etc., which are normally used for laboratories, testing facility institutes, and chemical industries, where there are chances of falling off the chemicals on the floor. The floorings provided for appearance requirement are by polished granites, kota stones, kadappa stones, marble stones, linoleum, etc. These types of flooring are normally used for hotels, lounges, residences, embassy offices, commercial institutional buildings. If we talk about acoustics, then acoustic flooring are constructed by wooden cork tile flooring, which are mainly used for theaters, auditorium, indoor stadiums, recreation buildings, etc. Anti-slippery floorings are mainly provided with ceramic tiles, checkered terrazzo tile, unpolished stone slabs, polyvinyl chloride or PVC, etc., which are being used for ramps, staircases, service areas, galleries, pedestrian areas of public buildings. The cavity flooring can be done by wooden boards with fire retardant paint and is provided for computer rooms. Now let's discuss about the classification of floor finishes. So all type of floor finishes can be broadly classified into two categories. One is cast in situ and second one is precast. In cast in situ, different type of floors are Indian patent stone flooring, that is generally called as IPS, then red oxide flooring, then granolithic flooring, then ironite flooring, next is terrazzo flooring, then mastic asphalt flooring, then epoxy flooring, then vacuum flooring, and the last one is China mosaic flooring. Under the category of precast, again you can divide into the three categories: factory made, naturally occurring, and man-made. Under factory made category, the floorings are cement tiles or terrazzo tiles, clay tiles, ceramic tiles, ceramic flooring, glass mosaic flooring, then acid proof tiles. In naturally occurring flooring, we have marble flooring, granite flooring, Kadapa or Shahabad, Kota, Agra, Katni stone, then sandstone. Under the category of man-made flooring, we have wooden floors, thin tile PVC sheets, then metal floors, then cavity flooring, and finally carpets. So these are different type of floorings that we use under different conditions. So let's begin with the Indian patent stone IPS flooring. The constituents of IPS flooring are cement, admixture, colored or white chips mixed with required water on reinforced cement concrete or plain cement concrete surface. It is done through panel system made by glass strip or aluminium strip. It is a basic type of flooring which provides good wearing properties. The thickness of the IPS flooring may be decided based on the requirement of the work. For example, for residential floor, the thickness of 75 mm is sufficient, whereas for industrial floor, the thickness should be at least 150 mm. Then we talk about red oxide flooring. Red oxide flooring can be made with cement, mud, or even lime. The oxides are available in many different colors. Though red is the most popular variety, other colors like green, blue, black and yellow may also be used. Here you see the red oxide flooring. Now we move to granulithic concrete flooring. It is laid using rich concrete made with the specially selected aggregate of high hardness, surface texture and particle shape, which is adapted for heavy engineering factories, workshops, garages and warehouses. Here you see this type of flooring. Now we move to ironite flooring. This is cement concrete flooring in rich ratio, normally 100 to 150 mm thick with nominal reinforcement. The top layer of 10 to 12 mm thickness is laid with iron chips or granules mixed with the concrete to make the top layer more hard. The floor finishing is done with the vacuum dewatered process and the top layer is finished with mechanical trowel finish. This is used in heavy material factories to minimize the damages to the floor. Here you see the ironite flooring. Now pavements with steel fiber reinforced concrete. The inclusion of fiber reinforcement in concrete can enhance many of the engineering properties of concrete, such as fracture toughness, flexural strength, fatigue resistance, impact and thermal shock. Fiber reinforced concrete, in addition to its normal ingredients, contains fibers of discrete length. The fibers may be of different diameter, shape and length and of different materials also. Some of the fibers generally used in fiber reinforced cement concrete are steel fiber, carbon fiber, glass fiber, plastic fiber, polypropylene fiber, nylon fiber, rayon asbestos fiber and also the basalt fiber. The important governing parameter is the aspect ratio, which is described as ratio between its length and diameter. Taking advantage of these properties of fibers, steel fibers are added to concrete in order of 1 to 2% by volume to produce hard wearing coat. Application of steel fiber reinforced concrete has been made in the areas of pavements, overlays, airport, railway, bridges, car parks, industrial floorings, etc. The thickness of fiber reinforced concrete overlay depends on the type of floor, intensity of loading, frequency of loading and its uses. For example, the thickness of steel fiber reinforced concrete layer would be 75 mm to 100 mm for industrial flooring. Now let's see cobblestone flooring. These are interlock pavers made of precast concrete available in several shapes and colors. They can be arranged in an unusual and pleasing patterns. As you can see here, this way these can be arranged. Cobblestone flooring has 5 important structural elements. First one is subgrade. The natural earth material found on site is generally used as subgrade. The main function of this element is to provide foundation for subbase. The next layer is subbase, a layer of gravel which is well compacted. Then above it is sand bedding. It is a layer of graded sand overlying by limestone screeding. The main function of this element is to provide proper leveling and finishing the pavers. The next is pavers. The exposed surface, generally the stone used for flooring. Then edge restraints. The support used around the perimeter of the paving is an edge restraint. The function of this is to hold the stone in tight position. Let's see now the steps for laying pavers. As a first step, prepare the subbase and then screed the sand bedding as shown in figure here A. Then lay out the pavers according to the pattern required as you can see in figure B. Now cut the pieces to fit the edges of the surface being paved as you can see in figure C. Then finally vibrate the pavers to their final level as you can see in figure D. Then sweep sand into the joints and vibrate it into place. Some typical types of pavers you might have seen on the road pavements. So different shapes of the pavers are shown here in this figure that you can see here. Now the applications. These are heavy duty, that container ports, loading docks, warehouses, airport aprons and railway platforms are made up by this floor. Then architectural point of view, driveways, garden walks, poolside pavements, shopping malls, crosswalks, parking bays and traffic lanes are made up by this architectural type floor. What are the advantages? They can be laid out in few hours as they don't need setting, curing and waiting. Practically these are maintenance free. If underground repairs are to be done, only that particular position is to be removed and replaced. You can easily remove these pavers from that particular position and again you can easily replace. You can place them. Here these does not involve any demolition or rebuilding. That way it is very easy. Then let's see blended marble tile flooring. 80% contains fine grains of marble blended with PVC as a binding agent are used to construct this type of floor. Then we have quartz reinforced flooring. These are manufactured by using polyvinyl chloride, plasticizers, stabilizers and pigments, and it is reinforced by a special quartz mineral to aim to increase resistance to abrasion, chemical attack and indentation. So this floor can resist these three things. Thickness varies from 1.6 mm to 3.2 mm. Now let's look at the cement bonded particle board flooring. So as it is clear from its name, it is having cement and particle board. This is made with 62% of cement and 28% wood. The wood used is of fast growing species like eucalyptus and cassarian. Due to adoption of a spatial manufacturing process, the boards acquire the strength and durability of cement and easy workability of wood. It is highly fire resistant, weather resistant and is termite proof. These three advantages we get in this floor. These boards can be used in mezzanine floor, and the minimum thickness of plank shall be 116 mm and supported on grid of 600 mm center to center. These floorings can be used along with any floor covering like PVC or carpets, etc. Now we move to diagnosis of defects in flooring. The defects may be defined as an imperfection, deficiency, or fault in the flooring element or structural component which adversely affects its functional performance or appearance. Some defects are the natural consequence of aging and normal use, but many premature failure can be traced due to bad workmanship, means lack of proper skill and care by the workers. Broadly, the different causes may be attributed to the following factors. What are these? Faulty design decision. Second one is construction methods. Then third one is user activity. And fourth one is maintenance. So now let us begin with faulty design decision. So this may be due to the failure to follow well-established design criteria in the choice of structural systems and selection of materials. Second aspect is ignorance of the basic physical properties of the materials. For example, failure to make allowances for the differing thermal and moisture movement of materials used in combination. Means when you are using two different materials in combination, then if you are ignoring their thermal properties and properties after the absorption of the moisture, because after absorption of moisture there may be swelling. So if you are ignoring these facts, and these properties will be different for the two different materials. So if you are using two materials in combination, then ignoring these properties may be very disastrous and it will be taken as a. Now the second factor is ignorance of the basic physical properties of materials. For example, failure to make allowances for the different thermal and moisture movement of materials used in combination. Means if you are using two materials in combination which are having thermal and moisture movement properties quite different, then you have to make allowances for this movement, thermal and the moisture movement. Otherwise there may be stresses that may come into the picture and there may be some problems, defects in the floor. Then use of new materials or innovative forms of construction which have not been properly tested before. This is often the result of uncritical reliance on manufacturers' literature quoting simulated laboratory test. Means you find something new in the market and that material has not been tested properly, and we are simply relying on the literature provided or the data provided by the manufacturer. But what is the wrong with it? The wrong here is that this literature provided by the manufacturer may be that all testing is done in ideal condition in the labs, or there may be some simulated laboratory tests. The material has not been tested in field conditions. Then the behavior of the material may be quite different from that provided by the manufacturer literature. So that may be a problem. Then another factor is misjudgment of user and climatic conditions under which the material will have to perform, because these may be different from the conditions which are generally taken while manufacturing of the material. Now, construction methods. The conditions under which construction takes place are often far from ideal and coupled with an emphasis on speedy completion, resulting in careless and skipped work. The materials may be perfect on leaving the factory. They get quite easily damaged in transit, during loading and unloading, unsuitable storage conditions on site, and hoisting and placing in position. So during all these activities, the material may be damaged or it may get defects. This problem can be tackled by introducing the quality assurance techniques. Essentially, these techniques consist of setting down appropriate inspection procedures and specifying levels of acceptance and rejection together with method of sampling and testing performance characteristics. Then another factor is user activity. You will find that certain defects may be related to the social attitude and unintended use of the occupier. That because of that social attitude, or there may be some problems that may not be intended one. There may be some accidents which are unintended. So defects may come into the picture in the flows. Then final factor is maintenance. If you keep the structures, floors well maintained, then of course they will provide you good service for a long time. Improper upkeep and not attending to the periodic maintenance and timely repair, then certainly it will lead to the problems in the flows. So in this lecture we discuss about the different type of flows that are there. Then we discuss about the diagnosis of defects in flooring. Next we will take up the common defects in flooring. So I hope you must have enjoyed this discussion. Now you go through the text provided to you and enrich your knowledge. Thank you.